Good day. In this lesson, I am focusing on algebra, but the main focus on algebra in this particular lesson is factorization of algebraic expressions. Now, before we go any further, I would like to just define a few terms that are very important in this discussion. Variable. A variable is a letter that is used in place of a number that is not yet known. Term. A term is letters and constants joined or separated by multiplication and division. That constitutes of a term. Expression. Expression is a number, or rather a group of terms that are separated by addition or subtraction. Now, if the expression is made up of only one term, it is called a monomial. And when the expression is consisting of two terms, it is called a binomial. When there are three terms, it's a trinomial. Anything more than three terms, we refer to it as a polynomial. Factors. A factor is a number or an expression that divides another number or expression, leaving no remainder. Prime factorization is the process where we write a number as a product of its prime factors. Now, this is going to be important in our discussion. Now, here are useful concepts. One of the most useful concepts that we're going to be utilizing in this particular section of factorization is the change of sign rule. It says when swapping terms of a difference, there arises a need to change the signs. And this happens because the two differences are equal in magnitude and different in signs. I'll just simply use a number. A typical number that we can use, 5 minus 3 gives us a 2, whereas 3 minus 2, whereas 3 minus 5 gives us minus 2. You can already see that when we swap the position of 5 and 3, the sign changes. Well, this does not happen when it's plus, but with minus, it does have an effect. Now, you'll almost think that if I were to multiply this with a negative, then for sure you will get a positive like the other one. So now it says to us, amongst the two statements, let's read the question. Which of the following statements are true? Now, if you look at the first one, x minus y equals to y minus x, it's not possible because you could be dealing with a situation where this is a minus 2 and this is a 2. Obviously, 2 and minus 2 are not equal. But if you look at the one on the left, we can see that if you say x minus y and you want to swap the y and the x positions, then you must put negative outside the bracket to cater for the change of sign when the two swapped their positions. So this will be correct in this particular case. So with this, then we are able to move on and say, whenever we want to change the positions of terms in a difference, we need to put that difference in brackets and introduce a negative sign outside. Now, these are the types of factorizations that we are going to discuss in this particular video lesson. We have what we call common factor rule, the difference of square rule, the difference and sum of cubes rule, trinomial rule, grouping rule, and the advanced trinomial rule. Now let us proceed and look at the common factor rule. Well, this is the easiest of them all. Easy because it does not require much except that we ought to simply find or identify the highest common factor of the terms involved and take the highest common factor outside brackets and leave all the other things inside the brackets. That is to say, the residue, what remains inside the brackets. Now here is an example: 2x squared y minus 10xy cubed plus 12xy. When we study this, we can see that 2 is the highest common factor amongst the constants. X is the highest common factor amongst the x's, and y is the highest common factor amongst the y's. So therefore, we're going to combine 2x and y to form the term 2xy and place that outside the brackets. So 2xy, and then inside the brackets, if you look at 2x squared y, we require that there must be x squared in the first term inside the bracket, to cater for in case you want to go back. So you say 2xy times x, you get back 2x squared y. Now the minus sign comes to the fore. Then in terms of the 10, we must place a 5 to complement the 2 so that we can get back the 10. Then the x is catered for, but y, we need y squared. Then the last one, we have a plus, and then that has to do with the 12. We need a 6. And then when it comes to the xy, it is already catered for. So when you say 2xy times 6, you get 12xy. So we're going to leave it as it is. So this becomes our factorization. If you look at the term, the expression inside the brackets, there is no common factor. So it is fully factorized. Here are other examples. If you can pause the video and try them yourselves, you can then come back and check the answer that we're going to present. Now, hopefully you found the answer that will be similar to mine here. So in this one, we have 2x squared y cubed minus 10x squared y squared plus 12xy. Again, we notice that 2 is the highest common factor amongst the constants. X and y are the highest common factor amongst the x and y's. And then we're going to combine that and make it a term 2xy outside brackets, and then complement the x with the x with x to make the x squared, and then y squared to make the y cubed. Then we move to the minus 5xy, then plus 6. Because already we have xy, so we're going to say plus 6 and end it right there. And then if you look at the expression inside the brackets, there is nothing common, so therefore we have factorized it. Now, if you look at the one that follows next, it looks a bit complicated and different from the two that we have already solved above. But basically, we are going to apply the same principle and say, if you look at between the two terms, if I may just simply highlight the two terms, it's this is just a term, and this is a term. Between those two terms, we have a highest common factor of x plus 1, or rather y plus 1. So we utilize that as our common factor, and then it is the highest common factor, of course. We place it outside and we protect it with brackets because it is a binomial, not a monomial. Now, that is very key for us because 2xy was a monomial, so we didn't need to put brackets. But y plus 1 needs the brackets because it's a binomial. Then, after we have taken out the highest common factor of y plus 1, we then are left with x with the first term and then plus 2 with the second term. Now that's our factorized version of the expression above. Here are some further examples. Here, of course, we're going to do exactly the same. We're going to say, but before we say that, we notice that we have a minus 1 and 1 minus a. Remember the change of sign. It is needed here because we have a difference, and this difference has changed the position. So now we want to force either the first or the second to have the same format as the other, so that then we can then take out the common factor. So in doing that, we will say, let's rewrite this as x a minus 1, and then introduce the minus outside, that is to change the sign, and then we say y, then we can then say a minus 1. If I may point out what we have just done here, we have introduced the negative, so the plus negative made it a minus y, and then we are now having the right to swap the position of the two terms inside that bracket. So we therefore have a minus 1, same as the other one. So we could have actually adjusted the first one, it will put a negative outside. But then let's continue with this one. So we then now say a minus 1 is a common factor, and then what remains is x minus y. So this becomes our factorization of that expression. Maybe let's find an alternative for that. What about if you say x minus x a 1 minus a, then plus y 1 minus a. Somebody now, you can already see that it will take a different approach. So 1 minus a will be common, and therefore minus x plus 1 y will be the other, and then we end up with 1 minus a multiplied by y minus x. Notice the position of y minus x over here. The position, this and this, they are opposite of one another, and therefore also this and this are opposite of one another. Think about it. If this is negative, it will meet another negative and makes a positive, whereas if this then is negative, this will be positive and a positive, and it still be positive. So it is consistent with what we discussed about the methods may be different, but the answers are the same, and they may not appear the same, but they are exactly the same. Okay. I will erase this one to make way for the sum underneath. Now, let us look at the last one of this kind. Trying to factorize this one, we realize that the stumbling block here is actually a simple one. We need to rewrite this as x, y minus 5, then minus, when you have a minus outside the bracket, the y, and then the plus will change to be a minus, so it's a minus 5. Therefore, now we can see that there is a common factor, or rather highest common factor of y minus 5, which we take out, and then we are remaining with x minus. Now here is another problem that normally pops up. It doesn't appear like there is something here, but there is a 1. So we revoke this one whenever there is a need. So therefore, we bring this one here to complete this. But good mathematicians do not write this one here. So we'll remove it. So this is what we end up with for this one. Next up, we discuss the difference and the difference of squares. Now, factors of this one is the sum and the difference of the square roots. For example, if you look at x to the power 8 minus 1, this is definitely a square because it is a square of x to the power 4 squared minus 1 squared. Then we are left with no choice but then to think of this as squares. So then if that is the case, then we can write this as a difference and sum of the square roots. So x to the power 4 plus 1, x to the power 4 minus 1. Then we can go further and say this x to the power 4 minus 1 is also a difference of squares. So we can go down and say x to the power 4 plus 1, and then place 2 brackets for the difference of squares. It's x to the power 2 plus 1, x to the power 2 minus 1. Also, the last one, x squared minus 1, is a difference of squares. Therefore, we can use the same definition of factorizing. So it's x to the power 4 plus 1, x to the power 2 plus 1, and then replace this with 2 brackets, x plus 1, x minus 1. Now, it is important for me to point out that we do not just jump to the last line, unless, of course, we are copying from the back of the book, where they normally put the answers. But when you are working this out, you work it bit by bit. The only unnecessary step is the first step, where I was showing that indeed x to the power 8 is a square. If you know it, you just simply proceed to these particular steps of importance. Okay. Here is another problem of interest. Now this involves binomials, but we can see clearly that these two are squares and it's a difference of squares. So in order for us to factorize this, therefore we're going to write it as a difference of squares, and it's a sum and a difference of of the square roots. So it's a plus b, and then we have a plus b, the square root of the first one, and then the second one is a minus a plus 2b, then we prefer to add just a bracket there, and then the other one is just simply plus a minus 2b. Then the second one, even if you were to put brackets, it wouldn't matter, because when you remove the bracket, the thing will remain as it is. But the second one, the bracket is important here, because when you remove that bracket, this plus here will change to be a minus. So if it was a minus, it will change to be a plus. Now the next step now is to write the solution, to complete the solution, or simplify rather. So if you look at the first bracket, it's a plus b plus a minus 2b. So a plus a, we get a 2a, and then b plus minus 2b, it's a minus b. Then we close that bracket. Then the next one is a plus b minus a, so a minus a is 0, and then minus 2b. So we have a b, pardon me, with the plus over here. I made a mistake. This hasn't changed. It is still a minus, sorry. When you remove the bracket, you have a plus b minus a plus 2b. Now, clearly, a minus b, a is 0. These two, they cancel one another. And then this one here, it will be a b plus 2b, so it's going to be 3b. This is our factorization. Of course, you would like to write it without the bracket, so it's 3b 2a minus b. Now, the last one of this kind requires a bit of thinking, but it is obviously doable. So when you have x to the power 2a minus 1, you need to see the difference of squares in this. Until you see that, you cannot touch this. But fortunately for us, we have in our examination means to write it as a difference of squares. So x to the power 2a can be written as x to the power a squared minus 1 squared. Now it looks like a difference of 2 squares. So we can then now say 2 brackets, a sum and a difference of square roots. So the first one will be x to the power a 1, a 1, a plus, and a minus. Now this is our factorization. So these are the solutions of the respective problems that we were given in this particular case. Then now we move to the difference and sum of cubes. Let us first look at the sum. The factors are as follows. First, if we have a difference and sum of cubes, we're going to look at a binomial multiplied by a trinomial. Now, the binomial will consist of the cube roots of the cubes. And then the trinomial will be constructed straight away from those cube roots. The first term in the trinomial will be the square of the first term in the binomial. The second term will be the product of the two terms in the binomial with negated or with a change of sign. And then the last term in the trinomial will be the square of the last term or the second term of the binomial. Now, let us look at an example. X cubed plus y cubed. So obviously the recommendation here is to have a binomial multiplied by a trinomial. The binomial will consist of cube roots, and then we will retain the sign plus. Now to construct the trinomial, we will square the first term, which is x squared, and then we'll multiply x and y, but change the sign, so we have xy, and then we change the sign, it's minus xy. Then we will add the square of the second term or the last term of the binomial, the y. So this is y squared. So this is the solution to this. So we can try the next one. Pause the video and try it. Otherwise, then you can then come back and look at our solution. So x cubed plus 1 equals to, we can place two brackets over here. One for a binomial, then the other for a trinomial. That's our pretty much our first step. And then the next step is going to be easy if we know how to find the cube roots of the respective terms. So x cubed, the cube root of x cubed is just simply x. And the cube root of 1 is 1. We retain the plus. Then we square x, we get x squared. We multiply x and 1, we get x. We change the sign, it's minus x. Then we square 1, we get 1. It's always plus over there. So it's simply rules that factorize those kind. Now, there are further examples. Let us just go through these ones quickly. After you have tried, you can check the solutions that I'll present over here. Now, given 27x cubed minus 8, here the 27x cubed, well, unless you understand that 27 is a cube itself, then you will have a problem identifying the sum of cubes. 8 obviously is 2 cubed, so we have a sum of cubes. So given this sum of cubes, then we're going to write out this as a binomial multiplied by a trinomial. The binomial will consist of the cube root of 27x cubed is 3x, and then the cube root of 8 is 2, and then the sum is retained. Then the first term on the trinomial will be the square of the first term, which is 3x squared, which becomes a 9x squared. Then when we multiply 3x and 2, we get 6x, but we would like to negate that, so it becomes a minus 6x. Then squaring the 2, we get plus 4. This is our factorization of the sum of cubes, 27x cubed plus 8. Let us look at x cubed plus 27 over 8. Well, 27 over 8 needs to be seen as a sum of cubes because 27 is itself a cube and 8 is itself a cube. So the cube root of 27 over 8 is actually 3 over 2. Then we can proceed with that knowledge to write the binomial multiplied by a trinomial factorization of the sum of cubes. So the factor here consists of the cube roots with the sum retained, it's 3 over 2. And then the second one, which is the trinomial, we're going to construct from the binomial. The first term of the binomial squared is x squared. Multiplying the 2, we get 3x over 2, and then we negate that, it becomes minus 3 over 2x. Then when we square 3 over 2, we get plus 9 over 4. So basically that is our factorization for this particular one. Now here is a little monster, but it's not a monster until you realize that we can swap the position of the m and the 3. It's called a commutative property, and then we can think of this as a sum of cubes. So rewriting this helps as a to the power m cubed plus 1 cubed. Therefore, we can then replace this with the factors the binomial and the trinomial. Where the binomial, what is the cube root of am cubed? A to the power m, it's a to the power m. And then the cube root of 1 is 1. The sum is retained. And then when we square a to the power m, we get a to the power 2m. And then when we multiply a to the power m and 1, we get a to the power m, but we would like to negate that, so it's a to the power m. And then when we square 1, we get 1 plus. That is our factorization again. So what happens when it's a difference? The difference of cubes follows the same format as the sum of cubes. The only difference is that the first term, the first bracket, which is the binomial, will take a difference. And then in the second bracket, which is the trinomial, the Mickle term, the linear term, which is the Mickle term, will always be positive in this particular case, meaning it negates the sign of the one found in the binomial. So we can go and proceed and do examples. Taking an example similar to the one that we did for the sum. So the instruction here says open two brackets, one for a binomial, the other for a trinomial. Then for the trinomial, we cannot do the trinomial, by the way, before we do the binomial. And then another thing is, it is very easy to do the binomial because it's just simply the cube roots of those cubes. So the cube root of x cubed is x. The cube root of y is y. And then we retain the sign minus. Pretty much easy. It's very easy. It just takes itself straight from the difference of cubes. Then now we're going to square the first term of the binomial. We get x squared. Multiply the two terms, we get minus xy. Then we negate that, it becomes plus xy. Then we square the minus y, it becomes a plus y squared. Now this becomes our factorization of this trinomial. You can pause the video and try your luck on the following below. Here is the solution, however. So x to the power cubed minus 64y cubed. Obviously x cubed is a cube, then 64 is a cube of 4. So we can think that 64y cubed is actually 4y all cubed. So therefore we have a difference of cubes. So to factorize this, we're going to open two brackets. One for a binomial and the other for a trinomial. Now, as for the binomial, we have x cubed, we have x for the x cubed when you take the cube root, and then we have 4y for the 64y cubed. Now, the difference is retained, and then we square the first term, we get x squared. We multiply the terms, we get 4xy, and then we negate that, it becomes plus 4xy. And then finally we square 4y, we get 16y squared. This is the final product when we factorize that on top. Now we can also factorize this one, which is a sum of cubes, but before we think it's a sum of cubes, we can also think it's a difference of cubes, especially because we are allowed in mathematics to change the positions when it's a sum. The property that we use is the commutative property. Now, since we're discussing the difference of cubes, we can as well think of just simply swapping this thing around, though it was going to work even if we were to proceed as it is, as if it's a sum. So we're going to write it as 1 minus 8x cubed And then we can put two brackets, one for a binomial 1 minus 2x, and then 1 squared is 1, 1 times 2x is 2x, minus 2x, and then negating that is plus 2x, and then minus 2x is plus 4x squared when you square it. Therefore, this is our factorization. If I had space, I was going to actually factorize it the other way with taking the cubes as a sum. Basically, the answer will be the same. Maybe let's make provision for that with a different color, of course. So it will be just simply two brackets, one for a trinomial and one for a binomial, and then this one will be a minus 2x, and this one will be a plus 1, taking the plus from the one on top, and then we will then say what is this, what is 2x minus 2x squared? We get 4 x squared, and then what is minus 2x times 1? It's minus 2x. Then we negate that, it becomes plus 2x, and then we try to multiply, we square 1, we get 1. Okay. Clearly, you can see that by commutative property, this term over here can be written in reverse as follows. 1 minus 2x, which actually gives us exactly what we got here. At the same time, this one here, if written in reverse, because we are able to swap the position of terms in addition, therefore both are the same. Here are some more examples or other exercises which you can try. Now let's discuss the solution. So we have 2x to the power 5y minus 16x squared y to the power 4. Now, if you look at this one in particular, you can see that there is a common factor between those two terms. So amongst the constants, 2 is the highest common factor. Amongst the x's, x squared is the highest common factor. And amongst the y's, y is the highest common factor. So combining 2 and x squared and y, we have the term 2x squared and y. So what remains inside is x cubed minus 8y cubed, which happens to pop up nicely as a difference of cubes. So therefore we're going to say 2x squared y, and then introduce a bracket for a binomial and a bracket for a trinomial. Now, as for the bracket for the binomial, we're going to have x, which is the cube root of x cubed, and we're going to have 2y, which is the cube root of the 8y cubed, and then we're going to retain the minus. Now, squaring the x, we get x squared. X times 2y minus 2y, it's a minus 2xy, but we will negate that, it becomes a plus 2xy. Then, when you square the minus 2y, you get plus 4y squared. Okay, so that becomes our factorization of the one on top. Now, factorizing the one below here, you can see here the highest common factor is a b plus 1. If you take that out, you remain with a cubed minus 1, which factorizes nicely into a binomial and a trinomial. So we have the binomial, then a trinomial. The binomial will consist of a, the cube root of a cubed, and 1, the cube root of a, 1, which is a cube, of course. And then we have a minus, which is retained from the difference of cubes. Now squaring the a, you get a squared, and then a times minus 1 is minus a. Negating that, we have a plus a, and then ultimately plus 1 squared, which is 1. This is our factorization of the one in the middle. Now, the last one can be factorized as follows. If you think of 2 to the power x cubed minus 2 to the minus x cubed, then we have a difference of cubes, so we can introduce a binomial and a trinomial. The binomial will be the cube root of 2x to the power 3 is 2 to the power x, and then minus 2 to the power minus x is the cube root of 2 to the minus x cubed. And then squaring the first one, we get 2 to the power 2x. And then multiplying the 2, they cancel one another. We get a negative 1, which will then tend to be a plus 1. So 2 to the power x times 2 to the minus x becomes 2 to the power 0, which is 1. Because of the minus here, we then have a plus. That's why it's plus 1. And then squaring that becomes minus plus 2 to the power minus 2x. Okay, that's our factorized version of that problem. Now we move to the trinomial rule. Well, the trinomial rule says the coefficient of the quadratic term must be 1 first, and positive 1 for that matter. Now, we then find two factors of the constant term that have a sum equal to the coefficient of the linear term. We then proceed to open two brackets, insert x as the first term of each, then we insert the factors of the constant term with their signs, taking the roles of operators. Okay. Sorry for the small mistake here of the spelling, taking the roles of operators. Now, let us look at this one, x squared plus 3x plus 2. If we were to factorize it like that, first of all, we notice that the coefficient of the quadratic term is 1. Then we proceed to put two brackets, and then the first terms of each bracket is x. Then we look at the number 2. 2 has two factors, 2 and 1. So, what are the two factors of 2 that add up to 3? It's 2 and 1, and they both take positive. But before we do that, actually the positive can also be analyzed from that very same trinomial. The sign of the constant tells us that the signs inside those brackets will be the same, and they will be of the kind shown over here. So therefore they will be plus, both of them. So it's plus 1 and plus 2. Okay. Maybe another example will clarify the matter. In this particular one, we notice that this is not arranged in the order that a trinomial should be arranged. So therefore we then rearrange it and say, let's start with the x squared term. So starting with the x squared term, x squared plus 5x minus 50. We say now it is arranged in the descending order, which is required of us if we are to successfully use this method. Now, clearly we can see that the coefficient of x squared is 1. Therefore, we're going to proceed and say, let's open just two brackets and place x as the first term of each. Then we ask ourselves, what are the factors of 50 that have a sum of, wait a minute, because of the minus in front of the 50, we are going to put different signs, plus and minus. And then this is to cater for the fact that the two constants, when they multiply one another, they give you a negative, and they can only give you a negative if they have different signs. Then now the next thing is to say 50. Which two factors of 50 give us a positive 5? Now it has to be a minus 10 and a 5. And a 5, because minus 10 times 5 gives us minus 50. So we need a 10 over here and a 5 over here. Then this is our factorization. The next one, pose it to work it out, and then look at the solution that we're presenting. But now if you look at this one, you can see that there is a common factor of 3 amongst those terms. Besides the fact that we don't have a 1, which requires us to stop, because this method will not work when we have a 1 there. But if you look at carefully, we have a common factor, and the highest common factor in this case is 3. Therefore, it is required of us to remove the highest common factor, and then as we remove it, we get 3 inside bracket. We have x squared minus x minus 20. Now, this is a perfect situation for us then, because now we have in front of the x squared, we have a 1. So we can proceed with our method and say 2 brackets x. Then we look at 20. We say we need 2 factors of 20, but before that, because of the minus, the signs will be different. 2 factors of 20 that have a difference of 1. It has to be a 4 and a 5. But then now, because it's a minus x that we are looking at achieving from the top bracket, we therefore put down there a minus 5. We make the 5 bigger and minus, so that it gives us the minus 1. So the 4 will be positive. You can expand this, it will give you exactly what we have at the top. This one here needs to be rearranged. So when you rearrange this as x squared minus 10x, be careful how you arrange this, and then plus 25. Now it is in the order that we can then say we can use this trinomial method. So we're going to open 2 brackets for the binomials, and x will be the first term of each, and then we're going to look at the sign in front of the constant term. It's a positive. This sign, which is positive, simply tells us that the signs that follow the x in each case are the same. But of which kind, then we look at the linear term, it has a negative, so we're going to say they are negative. Confidently so, they must be negative, both of them. Because when you multiply 2 negative constants, you're going to get a positive constant. Now, the next thing that we're going to do, we're going to look at the factors of 25 that have a sum of 10. Now, this happens to be a 5 and a 5. So, 5 and a 5, and this resolves our issue, just like that. Now, finally, I want us to look at the grouping rule before we go and do what you call the advanced trinomial method that I'm going to present here. Now, the grouping rule says the expression must be divided into groups, or in this case, into 2 groups of binomials. Then we use common factors to factorize the 2 binomials independently within the very same expression. And then after that, the resulting binomial itself is a common factor normally. And then it is placed out, and the residue is enclosed in a set of brackets. Look at this example. Here we can see that m with the first 2, and then these together. We can see that m is common with the first one. So we have m and then x plus y is the residue, and then plus n is common in this next one, so we have what? X plus y. Then we notice that x plus y is a common factor anyway, so we take it out as x plus y, and then what remains is m plus n. Now this concludes our factorization. Remember, when we are factorizing, we're aiming to take a many-term expression into a one-term expression. At the same time, we are expressing an expression in terms of its factors, and the factors are on the prime side of their nature, meaning they cannot be factorized any further. Here is another good example. So we take the first two as a group and the other two as a group. So we write the common factor of the first two terms is x squared. And then we are left with x minus 1. Now plus. When you look at the second one, we have 3x minus 3. The common factor there is 3. We take 3 out. We have x minus 1. Now it so happens that x minus 1 is now a common factor. So x minus 1 is a common factor. Then we are left with x squared plus a 3. This is now factorized. Now, let us look at this one. You can try it, pause the video and try it yourself, and then look at the solution that we're presenting shortly. Just want to remind you that if you are interested in supporting this channel, you can subscribe and help keep the numbers growing so that this channel can be self-sustained. I can be in a position to produce even more videos. Now look at this particular one. I suspect here it's going to be a challenge for us just to simply think we're going to group these and then group these, because then we're going to be stuck with a situation where x and y makes it a problem for us to conclude that they are common factors. So rather than we rearrange this. Sorry for the noise. We rearrange this. We say x squared minus y squared, and then we say minus 3x minus 3y. Then the next thinking is to think that this is the difference of squares. The first group is a difference of squares. And then we will then simply say, since it's a difference of squares, we're going to apply the difference of square rule and say 2 brackets, square root, plus and minus. And then say minus the common factor of the other binomial is 3. Then we are left with x plus y. Now clearly now we have 2 terms here. If I may highlight those 2 terms. This is a term and this is a term. The common factor amongst these 2 terms is x plus y. So we therefore say we're going to take x plus y out. And then what remains is x minus y minus 3. Now this is the factorization. We have just taken 4-term expression and we were able to put it as a 1-term expression by factorization, and it is indeed expressed as a product of its factors, or rather its prime factors, because they cannot be factorized any further. Now we are in a position then now to analyze the final method, which is the advanced trinomials. In this particular one, why we say it's advanced, it's because of the 2 or rather the coefficient in front of x squared. If this coefficient is not 1, then it requires us to utilize this method. What we are going to do here, we're going to take the coefficient of the quadratic term and multiply it with a constant. So in this case, it's the 2 multiplied together. So we get a 2 times 3, which is a 6. Now this 6, I prefer that we take this 6 and we write it in its prime form. So 2 into 6 goes 3 times, and then 2 doesn't go, 3 goes once, and then ultimately we can also introduce the 1 this side. Okay. Then we're going to then look at finding factors of this product, which is the 6, that have a sum equal to the coefficient of the linear term. In this particular case, those coefficients are 2 and 3. So 2 plus 3 will give us 5. So we then proceed and rewrite this expression as what? As 2x squared plus 2x plus 3x plus 3. Now notice that the 2x plus 3x is still intact. It is still 5x. And then everything hasn't changed as far as we are concerned, except that we have rewritten it differently so that we can then now think about other options. Now the next option that I'm thinking of here is to use the grouping method, as I can group this into 2 groups, and then in those groups I can see the first one has a common factor of 2x, so I put 2x out. And then if I put 2x out, I'm left with x plus 1. The second one has 3 as a common factor, so it's plus 3x plus 1. Then clearly x plus 1 is a common factor, so we write x plus 1, and then we multiply this with the residue 2x plus 3. Now this brings us to the factorization of this particular one. We can quickly check if it has been factorized correctly. The x, when multiplied with the 2x, gives us the 2x squared. The 1 multiplied by the 3 gives us the positive 3. Now if you multiply x and 2x, x and 3, you get 3x. 1 and 2x, you get 2x. When you add the 2, you get the 5x right there. So clearly it worked. So this becomes our solution. Now here are some further examples that we can, or exercises that we can use to master this particular work. Pause the video and try them, and then look at the solutions that I'm going to present. In this particular case, the first one, we have 4x squared minus 37x squared plus 9. Now the 4 is the problem here, so we need the advanced method rule. So now we're going to take the 4 and multiply it with the 9. So if say 4 times 9, we get 36. Then I would like to write 36 in terms of its prime factors. So 36, 2 goes 18, 2 goes 9, and then 3, and then 3 with 1 at the end. Now, I want to construct first of all, I think we need to polish out something here, which I see as a big problem. So the 2 here is supposed to be just x. Otherwise, this was typed incorrectly. Okay, so now we are looking at two factors of (36) that give us 37. Now, obviously, they must be of the same sign. So we then look at having 36 itself and 1, because then we can then just put the minus in front of the 2 to get what we're looking for. So writing this now, we can then expand this as a 4x squared minus, if you like, you say it's minus 36, but I would like to say minus x minus 36 x plus 9. Now let's take a pause and look at this. The minus x minus 36x gives us a minus 37x. The 9 is still there and the 4x squared is still there. Then we can then proceed and look at the grouping method and look at the first two binomials. What is common amongst those? We have x that is common, and then we have 4x minus 1. Then when you look at 36 and 9, the common factor there is 9. So we take 9 out, we're left with 4x minus 1. Remember that when we introduce the brackets, the minus sign forces us to have a plus. Otherwise, if you look at here, if you multiply this and this, we need to still get this positive. So the only way to get the positive is to change the sign inside, so that when the minus multiplies the sign inside the bracket, it changes the sign back to the positive. Now, at this point, 4x minus 1 is a common factor, so we take it out. It's 4x minus 1, and then what remains is x minus 9. This is our factorization. Now, I get the sense that this is a more powerful method that is also generic, actually. Now, let us go to the last one of the lot. 20k squared minus 9k minus 18. Obviously, because the quadratic term doesn't have 1, then we'll need to do what we have done with all the advanced trinomials. So we multiply 20 and 18. This gives us how much? This gives us 360. Then I'm thinking, let's write 360 in terms of prime. So 2 is 180. 2 goes 90 times. 2 is 45. 3 is 15. 3 is 5. Sorry, it's 5. Then 5 is 1. So we'll remember the 1 if there is a need for the 1, since we have run out of space over there. Now, what are the two factors of 360 that add up to 9? Now, they must have different signs, of course. So we're looking at now combining certain things here. So let's start by thinking of combining 8. The first group gives us 8. The first group gives us 8, and then while we have 8, the next group gives us 9 plus times 5, which is 45. 8 and 45 obviously doesn't give us 9. Then we're thinking, okay, let's multiply the 8 with the 3. We get a 24. The 24 and the 15 does give us 9. What is 24 minus? So if you go like this will be 24. And if you go like this, it will be 15. Then we are in a position to say 24 minus 15, we get a 9. Then how are we going to put it? We need a minus 9, so we're going to make the 24 minus and this plus. So we take this information, we go back and rewrite this. We say this is equals to 20k squared minus plus 15k minus 24k minus 18. Perfect. Then we are thinking now we can now factorize in groups of 2. So the first group, which is 20k squared plus 15k, has a common factor of 5. So we take 5 out, 5k out, we're left with 4k plus 3. Now, when we focus on the other group, the highest common factor between 24 and 18 is 6. When we take this 6 out, so it's a minus 6, then it becomes 4k plus 3, which of course we know how the minus turned out to be a plus, because when we reintroduce brackets, given that we have a minus outside, we need to cater for that. Now, clearly now 4k plus 3 is a common factor. We take it out. So it's 4k plus 3 out that bracket. And then what the residue is 5k minus 6. That is our answer. I hope you enjoyed this particular video, and clearly there is a lot to learn, and there are more exercises that you can actually try out yourselves. Please subscribe to my channel, Tulani Maths channel, or at Real School Maths, and then you will help the channel grow. I thank you.